Can you hear me, though?
Yeah, I can.
Okay, right. Good morning.
Good morning.
Right. Right. So last week we did the hydrocarbon part, ne? Right. We talk
Yeah,
about the properties and the basic structures and several things, ne? Right.
yeah.
So did you do the exercise I asked you to do?
Oh, yeah, I did some of it, but I couldn't like
Which
do
one you
all of
couldn't
it
do?
because I had like school assessments, like
Ah,
other exams
ah.
last week. My
Okay, you did.
chemistry one, my
Huh?
chemistry one is on the 18th of June.
Your chemistry one on
18th of June.
80, 18th
Like
July. You
like
said July?
June.
Ah,
Term test.
term test. Ah, okay,
Yeah,
okay.
yeah.
Next month,
So like I
18th.
had other subjects term test like last week, but
Uh-huh.
chemistry biology is in June.
Ah, right, right. So, what are the parts it's covered this time?
Just organic.
Ah, damn. But we can't finish it before 18th June.
Not the whole organic. You know
Uh-huh.
the syllabus? I sent you the syllabus. It's only up to 7.3 or 4.
Up to 7.4.
Yeah. So not the whole
That means
thing.
you mean 7.4 ne? Up to 7.4. Oh, that means 7 also there. I mean 7.4 also there. That means alcohol part.
Let me
You mean alcohol
yeah.
ne?
Yeah.
7.4 means alcohols. Means up to alcohol. We can finish alcohol today.
Yeah, up to 7, so including 7.4. Yeah.
It's okay. It's okay. Up to there, it's okay.
Mm.
7.4. Right. It's okay. It's okay. We can cover it.
Okay.
Right. After hydrocarbons. Let me check that part in the book. Oxidation. Ah, right, right. Yeah, yeah, it's okay. Right. So last time we finished that. Finished up to boiling points and melting points, ne?
Yeah.
We haven't talked about the solubility in water. We haven't talked about that part, and I just want to highlight some table. Mm, do you have that? You have that Pearson book near? You have? Is it with you now?
Yeah.
There is a table in page number 298. 298. Just mark that table, huh? Because I saw that kind of table in your paper. There's
Oh,
the
okay.
not table. I mean graph, not a table, graph. I always confuse graph and table. It's a
Mm.
graph. The
Yeah.
temperature. It's comparing the temperature. and
Boiling,
boiling
melting.
temperatures and boiling and melting point. You don't need to memorize that, but they gave the data and asked to plot a graph like that. I remember that kind of thing. Just mark it up.
Okay.
Right. Then write down a subtopic. Up to everything is okay, right? Is there any problems up to here?
No.
No. Clear? Ne? Ask
Yeah.
if you have anything.
Okay.
Right. Okay. Mm, don't keep your mouth silent. Ask. Talk. Huh? Then write down subtopic solubility in water. Solubility in water. Solubility in water. Solubility in water. Right. Let's talk about how things get dissolved in water first of all, right? Do you know how
Mhm.
things get dissolved in water? What are things dissolved in water? What kind of compounds dissolved in water?
Soluble compounds.
What kind of compound?
Soluble stuff.
Yeah, soluble compounds. Yeah. Okay. What are the soluble compounds in water? What kind of compounds are soluble in water?
Um, uh,
Solubility. Let me say. Solubility. When it comes to solubility, there are two type of solvents and solute. Remember solvents and solute.
yeah. Solute is what's dissolved in the solvent.
Yeah, okay, good. So basically, there are two type of solvents and solutes, right? We call polar and non-polar. You already know that, right? Polar and non-polar. Remember, polar compounds, non-polar compounds, right? Right. So whatever the chemical in this world, you can categorize into polar or non-polar, right? But generally we can categorize like that. But remember, this concept, it's not like, how to say, it doesn't like male and female, right? When we say, now I can't say that name of them, right? Early days I can say male and female, right? now now there are some people in the middle, right? So let's say, in this let's take an animal, right? Animal has only male and female, right? So, right, this concept doesn't like male and female, huh?
Okay.
Because it's like a spectrum, right?
Yeah.
Not in your level, right? But uh, because if it's how to say, it's like a spectrum, the idea is, that, mm, covalent compounds and ionic compounds,
Yeah.
same theory, ne?
Mhm.
Covalent and ionic, right?
Yeah.
So we can find mainly ionic, mainly covalent. There's no any, these compounds, it's like a spectrum. There's no any boundary, right? There's no any exact boundary just after that covalent, just after that ionic, right? There
Yeah.
are some concepts, right? There are some scientific standards, but otherwise there's no any those standards made by us, right? Otherwise we can't categorize into exactly covalent, like there's no any boundary, exact boundary. That's what I said, right? Same theory applying here, right? But we can generally you can say this compound is polar, this compound is non-polar, right? That's the real chemistry, right? But generally we can categorize anything into polar and non-polar, right? So
Okay.
some compounds are very polar, some compounds are not that much polar, right? That's what I said, right? It's
Mhm.
varies, right? It's varies. So just keep it in mind, but this is the theory, the basic. So now we can't use male female example.
Mhm.
Right. Now it's a spectrum, is it? Yeah, especially in your countries, it's a spectrum. Right? Male become female, then female become male. Right. So polar, non-polar, right? Whatever the
Yeah.
compound, you can categorize into polar or non-polar. So how to categorize into polar or non-polar? What are the factors we have to check? Basically, if anything has polar bonds, what are the polar bonds? It's called polar compound. If anything has non-polar bonds, we can call it non-polar compound.
Non-polar.
Another thing we have, other than these two, we have ionic compounds, right? Ionic compounds. We can't categorize ionic compounds into these two, but generally ionic compounds goes with polar, right? So the theory is polar compounds dissolve in polar solvent, right?
Yeah.
Polar compounds, you know that, ne? You already
Mm-hmm.
know that, ne? I just reminding you, right? Then non-polar compounds dissolve in non-polar solvents. Then ionic also dissolve in polar compounds, right? So
Yeah.
what is water?
Polar.
Polar, yeah, yeah. How things get polar? It should have polar bonds. Polar bonds means it should contain molecules, I mean atoms like F, O, N, C, especially these three. N and Cl very similar, very similar. N and Cl very similar. So when it's make bonds with oxygen and chlorine, right? This kind highly electronegative atoms, right? When they make bonds with highly electronegative atoms, the let's say HC, HO bond, right? So what happened? The electron cloud pull towards the oxygen atom, right? Electron
Mm-hmm.
cloud pull towards the oxygen atom, right? Due to that,
Yeah.
what happened? What happened due to that? The bond become polar, right?
Mm-hmm.
That's what is a positive, slightly positive. That's kind of polarity, right?
Yeah.
Right. So this kind of compound, polar compound, right?
Mm-hmm.
So what is a polar compound? So any polar solute can dissolve in water, right?
Yeah.
Then non-polar doesn't dissolve in polar compounds, right? So when things get dissolved in water, especially what happen, it's make intermolecular interactions, right? When something dissolve, this thing happen for any solvent, any solution, they make intermolecular interactions with each other, right? That's how they dissolve, right? So
Mm-hmm.
when you put ionic compound, the ion goes to the water, and then water molecules cover the iron surface, right? That's how you know that. So that you already know that, right? You might know that. Here it doesn't matter. I don't need that much deep. So here the basic is polar, non-polar, right? Then let's go to the hydrocarbons and most organic compounds, right? So especially now here hydrocarbons, right? So
Mm-hmm.
hydrocarbons, are they polar? Do they have polar bonds? Hydrocarbons.
Uh,
What are the bonds they have? CC and
CC and
CH.
HC.
Yeah, CC, CH, and maybe CCl if you go to uh, hydro halides, right? Halides, right? Still CCl. That's not the polar, right? It's relatively polar, but not enough to dissolve in water, right? So other basic hydrocarbons aren't polar; they are non-polar. Right? Actually, most of the organic compounds, lot of organic compounds are non-polar. right?
Mm-hmm.
Some of them are polar, most of them are non-polar. Uh,
Yeah.
Generally, the general idea when you need to classify when something polar or non-polar, one of the method I always say, think whether it's soluble or insoluble in water, right? If anything is soluble in water, that should be a polar compound, right? If anything
Mm-hmm.
soluble in water, that should be a polar compound. If
Yeah.
anything insoluble in water, it should be a non-polar compound, right? That's the basic theory, right? Example, kerosene. Kerosene doesn't dissolve in water.
Well,
It should be a non-polar, right? You have to think about the bondings also, but simply you can think that. Then, mm, alcohol, not all the alcohols. Alcohol that we drink, I'm not drinking, right? People drink, right? Alcohol that people drink, right?
yeah.
Which alcohol? Ethyl alcohol, right? So
Yeah.
then how about it? It
Whole
should
lot.
be it should be pole. It is all in water, right? So in the when you look at the
Because you can mix it.
yeah, we can mix it. When you get the bottle, you can't find two layers, right?
Yeah, yeah.
It's just one mixture, right? If you saw two layers, or then something wrong, right? It
Yeah.
can't be, right? So if you don't have any way to find it, just think whether it's dissolved in water or not. Then that's easy, right? So the factors effect on dissolving basically bondings, right? Bonding nature, right?
Yeah.
You have to check about, you have to consider about bonding nature. According to that, you can predict whether it's dissolved or not, right? And
Yeah.
another thing, even in alcohol, right? I'll discuss it, but here I'll just say the basics. So let's take alcohol, right? CH3, CH2OH, right? So this is the one that we use, right?
Mm.
That's this undissolved, well dissolved in water, because it can make hydrogen bonds, right?
Mhm.
They should make hydrogen bonds, not
Yeah.
not hydrogen. Yeah, it should make hydrogen bonds because it's oxygen, right?
Yeah.
So this is the R group, right? This part is the R group. We call R group, right? We call R group
Mm-hmm.
the carbon chain. When this
Yeah.
carbon chain getting longer, what will happen? Do you remember? Do you
More
remember?
bonds.
Uh, when carbon chain getting bigger, the solubility decreases,
Increase.
right?
Oh,
You
decrease. Yeah.
you might saw this kind of thing in biology. Remember the cell wall? Sorry, not cell wall. I mean plasma membrane. Plasma membrane. You draw something like this near, right? One
Oh,
part
the
is
phospholipid.
huh?
Phospholipid. The
Ah, phospholipids.
phospholipid.
Phospholipids, right? So one part is what you call that
Whole lot and
hydro,
then
hydrophilic and
phobic.
hydrophobic, ne?
Yeah.
Hydrophobic, ne?
Yeah.
Right.
Yeah.
So hydrophobic means phobia, right?
Water hating.
Yeah, hating, right? Water hating, right? Afraid to water, right? R groups hydrophobic, right? The
Mm-hmm.
part that can form bonds with water, hydrophilic. Philic means loving. Yes.
Yeah. Yeah.
Philic means loving, hydrophilic. Wherever you saw philic means loving, right?
Yeah.
Loving with water, right?
Yeah.
Right. Loving with water, right? Okay, let's write down a little bit. Right, when they mix together, what we call, sorry, I mean dissolving, right? When they make two
Solution.
layers, when you mix it, we call, I mean when it's not, when solutions, sorry, liquids doesn't dissolve with each other, we generally call immiscible liquids, right? You know
Yeah.
it when we say
Yeah.
immiscible liquids,
Yeah.
right? Water is a polar compound. First point. Water is a polar compound. Water is a polar compound. Water is a polar compound.
Yep.
Water is a polar compound. Therefore, 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 polar polar solutes, polar solutes, polar solutes dissolve in water. Right. Next point.
Mm-hmm.
Next point. Hydrocarbons are nonpolar compounds. Hydrocarbons are nonpolar compounds. Hydrocarbons are nonpolar compounds.
Yep.
Next point. No, just continue. Nonpolar compounds. Their dispersion forces
Yeah.
their dispersion forces
Mm-hmm.
between water molecules and between water molecules and their dispersion forces between water molecules and hydrocarbon molecules hydrocarbon molecules hydrocarbon molecules
Mm-hmm.
hydrocarbon molecules are not strong enough are not strong enough are not strong enough to overcome to overcome to overcome the strong attraction to overcome the strong attraction between between between
Mm-hmm.
water molecules between water molecules. Right, so what it says, to dissolve, right, to dissolve these solvents, to dissolve in a solvent, right, let's take, right, let's say there are two compounds, right, so one is here, so water has hydrogen bonds, right, water has hydrogen bonds, so when you try to dissolve another compound, right, so they start to make intermolecular interactions, right,
Mm-hmm.
so they have to penetrate the water, right, solvent, right, they have to mix, means they should penetrate, these particles should penetrate with each other, right, so when they penetrate, some hydrogen bonds break and other particle goes in between water particles. That should be, that
Yep.
should happen, right.
Yeah.
Mixing means they should go inside of the particles, in
Mm-hmm.
between particles, right. So
Yeah.
here, to go to the in between particles, the hydrogen bonds in between that, let's take two particles, right? So there are some hydrogen bond, right? So the new one have to break the hydrogen bond and should go into the middle, right? There are two couple. There's a couple, right? Right. If you go
Yeah.
into the middle of that couple, right? What you have to do? You have to break that. You have to break it, right?
Yeah.
You have to break it and you have to make a new one, right? You have to make
Yeah.
new relation, right? Something like
Mm-hmm.
that, right? The problem is they they don't the strength of this bond, right, which is, you know, that hydrocarbons have only dispersion forces, right? The intermolecular interaction is dispersion force, right? The
Mm-hmm.
problem is this dispersion forces not enough to break hydrocarbons and form better bond, right?
Yeah.
This dispersion forces doesn't is strong enough to make new one,
Okay.
right? That's why
Yeah.
we say it doesn't dissolve, right? It doesn't dissolve. The reason is in the intermolecular interaction perspective, right? We can explain same thing in different way, right? When we looking at the intermolecular interactions, this thing happen, right? These
Mm-hmm.
molecules, right? Hydrocarbon molecules can't break the hydrogen bonds and cannot go in between water particles, right?
Yeah.
That's why that's what that sentence explain, right? Method underwear cannot go to the middle, right?
Yeah.
Breaking. Then what may halogen, right?
Mm-hmm.
Halogens, let's say something like, I mean, halogens. Halogens, right? So, as I said, they have kind of a higher solubility. I mean, not solubility, kind of a relatively higher polarity than basic hydrocarbons, but still that polarity isn't enough to dissolve in water, right? Still that intermolecular interactions aren't strong enough to make bonds with water, okay?
Mm-hmm.
But they have relatively higher interactions because they have dipole interactions, right? They have
Yeah.
dipole, right? Because of halogen, right? The bond is once little bit, I mean, it's polarized, right? It's polarized, but that polarity doesn't enough to dissolve in water, okay?
Mm-hmm.
Here it's a C, the bond is Cl, right? This is the
Yeah.
bond CCl, right? This polarity doesn't enough, right? This is
Mm-hmm.
polar, but this polarity doesn't enough. Remember HCl, right? Cl and hydrogen, right? This polarity is enough to dissolve in water, right? HCl, you know, acid, right? Hydrochloric acid, right? That's how it's
Mm-hmm.
work, right? CCl not enough. This one is enough, right? So,
Yeah.
but this one have still doesn't dissolve in water. Halo, what you call them? Halo halogens still doesn't dissolve in water, but having higher polarity than hydrocarbons. Okay,
Yeah.
write down. Halo, next point, write down as a point. due to the polar nature of 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 halogen carbon bond, halogen short line carbon, halogen short line carbon bond, halogen short line carbon bond, carbon bond.
Mm-hmm.
Just read that sentence again.
Due to the polar nature of halogen short line carbon bond.
Bond. Haloalkanes, haloalkanes, haloalkanes
Mm-hmm.
haloalkanes have slightly higher have slightly higher slightly higher slightly
Yeah.
higher solubility, slightly higher solubility, slightly higher solubility,
Mm-hmm.
slightly higher solubility than hydrocarbons, slightly higher solubility than hydrocarbons, slightly higher solubility than hydrocarbons.
Mm-hmm.
Right. But but the solubility is still but the solubility is still very low, but the solubility is still very low,
Mm-hmm.
solubility is still very low because of the because of the still very low because of the right, aren't you writing?
What? Because of the.
Because of the overall influence of the overall influence of the overall influence of the
Yeah.
overall influence of the overall influence of the dipole dipole interaction is dipole dipole interaction is dipole dipole interaction is small, small. You are writing too fast, ne? I mean, normally students don't write that much fast. That's why naturally I'm just normally I sit very fast, but then I slows down, right? So I can go fast with you. Okay, right? Yeah, that's it. Is it okay?
Yeah.
Yeah. Give me a second. Right. There's another thing happened in haloalkanes. Um, this C, I'll write X. X means halogen, right? X means
Yeah.
halogen, right? So this bond, this bond is kind of a shorter, right?
Mm-hmm.
Yeah, this bond is a little bit shorter, right?
Yeah.
So I mean relatively short, right? And when the carbon chain increasing, when the carbon chain increasing,
Mm-hmm.
that this bond is short, and the influence of halogen, right? The influence
Yeah.
of halogen decrease when the R group getting bigger and bigger, right?
Mhm.
When R group getting bigger and bigger, this effect means, as I said, this is kind of a dipole, right? This is a dipolar one, right? So that kind of effect will reduce, right? And
Yeah.
most of the time halogens are denser than water.
Mhm.
Halogens are denser, right? That means when you put halogen and water, then I mean hydrocarbons, water goes to the bottom, that hydrocarbon is floating, kerosene, right?
Yeah.
Kerosene is floating. But here, halo alkane goes to the bottom, and water is floating, right? Water is floating,
Yeah.
right? So remember that haloalkanes generally denser than water, right?
Yeah.
But hydrocarbons generally, I mean, it's depend, right? When the carbon chain getting bigger and bigger, they getting denser, right?
Mhm.
So, but haloalkanes generally denser than water. So write down that also. First point. The effect of haloalkane, sorry, the effect of halogen, the effect of halogen
Mhm.
is decreases, the effect of halogen is decreases, the effect of halogen is decreases,
Yeah.
the effect of halogen is decreases when hydrocarbon is increasing, when hydrocarbon is increasing.
Mhm.
Hydrocarbon means, don't say hydrocarbon. When
Chain.
carbon chain increasing, right? Carbon chain increasing. When carbon chain increasing. When carbon chain increasing. Right?
Mhm.
Then next point.
Yeah.
Next point. Many haloalkanes. Next point. Many haloalkanes are denser than water. Many haloalkanes. Many haloalkanes are denser than water.
Mhm.
Right. So underline denser than water.
Okay.
Right. Okay. Then we have to talk about solubility in organic solvents. Nothing to write that. Nothing to teach also there. Though there is a small paragraph in the page number 300. Nothing to explain. Just read it by yourself later, right? Solubility in organic solvents. They dissolve in organic solvents, right? They are
What
polar.
page?
They are non-polar, right? Both are non-polar.
What
So then
page?
300. 300.
Okay.
Nothing special, right? And nothing to teach thing, right?
Do you want me to copy the diagram?
Huh? No,
Do you
no,
want me to?
no need. Just read it. Nothing.
Oh no. Do you want me to copy the diagram on the board?
Which one? Ah, no, 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 no need. No, no.
Okay.
When I say denser than water, you know, ne?
Okay. Yeah. Yeah.
Nothing to write. Nothing to write. Right? When you saw it denser than water thing, right? You know how
Yeah.
it plays, ne? Mm, then that solubility in organic solvent, it's important. Here they talk about some that crude oil spills in the sea, right? Crude oil
Mhm.
spills, right, due to different reasons, right, damages. And so crude oil You know crude oil. You know what is crude oil, right? Right.
Yeah.
So crude oil, we take that petroleum fuels using crude oil. I mean, separating crude oil, right? It contains several compounds, right? So
Mm-hmm.
they just, it's a mix. Basically, it's a mixture, right? Different places have different type of crude oils also, right? Not all the crude oils are similar, right? So then when that kind of thing happen, right? Crude oil spills.
Yeah.
We have to, I mean, people, they have to manually remove that, right? Manually remove that from the sea surface, right? And then the crude oil is remain like a thick layer, right?
Mm-hmm.
And they have new methods to remove that. Even they use bacteria also now, develop
Yeah.
bacteria, right? They you know that, man? Have you heard about those things? Removing crude oil. I mean, nothing special there. So
Yeah.
basically, basically they just manually remove it. They use different methods, and those they have to use some solvents also, right,
Mm-hmm.
to remove that, right, to clean the
Yeah.
clean the water, right. So they separate it and they, yeah, that's it. Nothing there, nothing important. Right? Why it's why do we need to remove that? What happen if you keep it without removing?
It's bad.
It's bad. What kind of bad?
Um.
Yeah, its effect on basically marine life, right? Marine
Oh
life,
yeah, the
because
environment.
yeah,
Yeah.
the environment, how basically there, I mean, there are a lot of things happen, right? Even
Mm-hmm.
birds also get effect. Effect means, um, you might show some videos. I mean, birds get, I mean, they will die because, I mean, anyhow, if they contact with that crude oil, it's just, they can't fly, and then just, um, they become dark color, dead body, right?
Yeah.
කළු වෙලා නිකන් මැරලා යනවා, right? So
Mm-hmm.
basically the bottom sea bottom doesn't get enough sunlight, right? The marine
Mm-hmm.
life in the bottom, first it start to
Yeah.
dead, right? Then, I mean, no food in the bottom, and that environment will die, right?
Mm-hmm.
These crude oil spills aren't small ones, huh? Right?
Okay.
Those are very, I mean, it's covered huge area, right? Huge area of the sea surface, right? Not a small ones, right?
Yeah.
Right, then you can do, there's a small activity in page number 301. Key questions. Mark it,
Mm-hmm.
and then impacts of uses of organic substances. Mm. Yeah. Let's talk about this part. We have talk about this. These are practical uses. No need, right? Let's discuss that part. So, where we use these organic substances, right? Why it's this much important? Actually, I should ask where we don't use that, where we don't use organic substances, right? So,
Yeah.
starting from what? Food, medicine, ne? Right? Everything.
Yeah.
Yeah. Now everything is synthesized, and the theory behind of those things, organic, right? Organic conversions and those things. And then when we goes to things that we can't eat and drink, mm, you know that plastics, right? Plastics, and it was fuels, then that paints,
Mm-hmm.
everything is based on organic solvents, organic compounds, right? That's how it's work,
Yeah.
right? Actually, we use organic compounds, I think, from the very beginning. The very beginning means when we start civilizations, we use
Mm-hmm.
it. Ne? We use alcohols, I guess, before 4,000, 6,000 years ago, right? One of the oldest organic compound, right? Alcohol, right?
Yeah.
And you know, I mean, yeast also very old, right? People make bread very early days, right? Ancient civilizations, they make not exactly bread, but something related to bread, because they use fermentation, right?
Yeah.
They use, I mean, early days they had natural things. I mean, natural means we didn't have any synthesizing methods, right? So
Mhm.
based on, they use those things based on natural, I mean, microbes, basically microbes, right? So then drugs completely based on organic compounds, right? So we have to synthesize those drugs, right? Then
Yeah.
example, mm, you know, insulin, insulin.
Yeah.
Early days. Do you know how they use, how they get, how they make insulin early days? Very, I mean, very early days.
No.
They extract it from the animals. You know, cows, right? Yeah, they kill them. I
Yeah.
mean, let's kill them for meat, right? After they separate pancreas, they separate the pancreas, and then they extract it. That's how they take insulin early days. Now, after that, not now, after that, I mean, after new methods developed, we just synthesize it now, right? Synthesizing, chemically synthesize it, because
Mhm.
the chemical is chemical. It doesn't matter how it's come, right?
Yeah.
Wherever it comes, it doesn't matter. We can synthesize it. Nowadays, we synthesize almost all the compounds, but early days, we didn't have any ways to synthesize those drugs, right?
Mhm.
I mean, most of the drugs we just extract. We have extraction methods. Extracting means, you know, I mean, still we are extracting. We extracting from plants, or things we let the things to do microbes and then extract, right? We have a great relationships with microbes, right? We let the
Yeah.
microbes to do that, then we extract it, right?
Mhm.
Example, you know, penicillium, not that, right? Penicillium, right?
Yeah.
Penicillin extracted from the microbes, fungus, and you know,
Mhm.
those drugs. I mean, drugs means like heroin, cocaine, that kind of thing. Those are also extracted from plants. Do you know?
Yeah.
Cocaine, cocaine, cocaine extract from a plant called coca.
Mhm.
Coca leaves. Coca leaves. There's a plant. That leaf contain cocaine. It's a substance, right? So cocaine, actually, the people in, I mean, native people, especially I guess in South American, I guess. So the native people eat that leaves like we drink tea, right?
Yeah.
The way, I mean, like we drinking tea, they just eat
Mhm.
that. When they get tired,
Oh.
they eat that coca leaves, right?
Mhm.
So then, I mean, but the problem is that one leaf contain very small amount of cocaine. It doesn't matter, right? It gives
Yeah.
some strength, and I mean, they can work. But when you extract it, or then it become a drug. Actually, it's used for treat mental ill people early days, very early days. But later, they misused it, right? That thing happened, right? After some
Yeah.
time we start to misuse it, right?
Mhm.
So now it's become a expensive drug, right? So so that kind of things we can chemically synthesize now, right?
Mhm.
You know, there's another one called morphine. Morphine also
Yeah, I
extract
know.
from morphine. It's a early one,
I know.
early
Yeah.
days. That comes as a uh, what me painkiller. Morphine, it comes as a painkiller.
Mhm.
So after that, it's one of the greatest painkiller, one of the greatest painkiller in, especially in World War Two, I guess. World War Two, that's the painkiller you have, right?
Yeah.
Because if you want to know how much it's powerful, let's say you lose your arm and leg, right?
Yeah.
still you can work, still you can
Yeah.
uh, stay
Oh.
active using morphine, right? That much
Yeah.
powerful after losing your side of the body, right? In World War, right? People
Mhm.
still, there are some people after survive, right? They took the painkiller and then if they have a chance, they can survive. So that kind of things happen.
Yeah.
So morphine, I guess morphine change into another compound using synthesizing methods, right?
Mhm.
Mm, another example, right? You don't need to memorize those examples, right? I just want to say this. I mean, these conversions happen, right?
Mhm.
Example, you know, you heard about when you go under sunlight, morning sunlight, we will get what?
D.
Vitamin D. Yeah. You do know how it's happened? Vitamin D, it's very interesting. Vitamin D and cholesterol.
Yeah.
Cholesterol,
Mhm.
fat, cholesterol. Cholesterol molecule and vitamin D are very similar,
Mhm.
right? Those two molecules are very similar. So,
Yeah.
what happens when you go under sunlight? UV UV rays can break down. I mean, not breaking, it's change, right? Changing into vitamin D, right? Cholesterol. That's what
Mhm.
happened under sunlight, right? These two molecules are very similar,
Yeah.
right? So that kind of things, right? It's organic, right? It's a conversion is naturally happen, right? This kind of things happen. Oh, it's enough funny. It's boring.
Mhm.
Nothing to explain, right? Right. Then economic and social cultural implications of obtain using hydrocarbons. Can't eat. Just read that part and nothing to explain. Simple. Just several things, right? They talk about this. Just some people are striking, right?
Mhm.
Safe handling. Nothing is special. Then do the chapter review exercise 30 306. Yeah, 306. Okay. Before we start the next part,
Mhm.
take a break. 5 minutes break. Take a
Oh.
5 minutes break and drink some water and yeah.
Oh, why?
Yeah. I mean, I should give interval thing. It's better, isn't that better? Taking interval, right?
I
Just
don't need a break.
go away and then just come back. Then get refreshed.
I don't need a break.
No, just take it. Why? Why don't you like break? Go ahead and just take a break with it. It's better. Drink some water and then come. Get refreshed. Why? Don't you like? Take a break with it. Go. Turn off the camera and go. Go with it. Why are you staying?
Because.
Come at 8:10. Oh, take a water break. Go. Okay, then let's move to the next part. Then write down a topic. Write down a topic.
Mhm.
Chemical properties of hydrocarbons. Topic: chemical properties of hydrocarbons. Chemical properties of hydrocarbons. Chemical properties of hydrocarbons. Right. Here we mainly focused on chemical reactions, right? Chemical reactions shown by hydrocarbons, right? So there are some types also, the common types, right? Here you don't have to learn that, right?
Yeah.
So if you need, I'll explain it later, right? There are categories, right? But here we just talk about the basic reactions, right? When we come to hydrocarbons, as you know, we can easily burn them, right? We can
Yeah.
easily burn them, right? So that means combustion, right? That's what you do in vehicle engines and to make fire, right? You know, we burn coal, right? Those things basically, carbon, right? So write down a subtopic: combustion of alkanes in air. Combustion of alkanes in air, right?
Yep.
So what are the products formed when we burn hydrocarbons?
Carbon dioxide.
Okay, carbon dioxide, and basically reaction with oxygen means, I mean, combustion means reaction with oxygen, right? Let's say CH4, right? The basic is combustion. Keep it in your mind. Every element should oxidize into maximum level. Every element in the compound should oxidize into its maximum level, right?
Yeah.
Carbon means carbon dioxide,
Yeah.
right? Carbon dioxide. Hydrogen, what? H2O, right? Hydrogen H2O. Then you have to balance it, right? You have to balance it anyhow. To balance, right? Now it's 2, 2, right? Right. These are very common reactions, right? Very easy reactions. Just burn, right? And remember your, I mean, you use gas stove, right? It's most of the time you can see the blue color flame, ne? Your gas stove, it gives blue color flame, ne?
Yeah.
Do you have a gas? Are you using gas in your area? I
Yeah.
mean, your house?
Yeah. Yeah.
Okay. Right. Okay, then aren't you cooking? Are you cooking?
Sometimes, yeah.
Sometimes, right? Okay. Um, so it's a blue color flame. It's a blue color flame,
Yeah.
right? Um, what happen if it's sometimes it's get yellow due to
Because of
some
oxygen.
reasons? Huh?
Because of oxygen.
No, not because of oxygen, right? This is a reaction with oxygen, right? I'm talking about the flame. So generally it's blue color. Due to any errors, it's become yellow sometimes. What can you see when it's get yellow? Can you see any differences? So haven't you observed any differences? Anywhere? No, not there. Not in the gas burn, right? If you cook or do something under yellow flame, what you can
Yeah.
observe? What you can observe? Have you observed any differences?
No.
Have you observed the black color powders collecting under the bottom of the
No.
surface? No. During, we call it, I mean, yellow color flame, we call it incomplete combustion, right? Incomplete combustion. During incomplete combustion, I mean, incomplete combustion happen due to the lack of oxygen, right? When it doesn't have enough oxygen, right? When enough oxygen, I mean, oxygen should be there, but need enough oxygen. I mean, excess oxygen to
Yeah.
to happen this, right? To produce carbon dioxide and water. Only carbon dioxide and water. But when the oxygen amount is lower, the thing happen, it start to produce carbon and carbon monoxide. Other than these two, carbon dioxide and H2O also formed, but other than that, it form carbon and carbon monoxide. Okay, that's why when you cook under yellow flame, you will get black color powder, which is carbon, collect under bottom of the pan, right? Pan එකේ bottom එකේ අර කළු පාටට බැඳෙනවා. If you cook on white flame, you have a family views. I mean, you may even don't know why yellow color flame, right? You don't cook on yellow color flame, right? So this is complete combustion, right? Complete combustion means basically completely oxidized. And other one which is incomplete, in that case it releases carbon monoxide and carbon, right? These are also released, right? With these two, carbon monoxide and carbon also released, right?
Yeah.
Incomplete combustion happen with low amount of oxygen, right? When enough oxygen, not enough oxygen present. Okay. One of the common reaction is among actually almost all the organic compounds we can burn, we can use as a fuel, right? You know, alcohol also. I mean, nowadays there are some vehicles completely run by alcohol, completely run using pure alcohol. Do you know? There are some vehicle engines completely run by alcohol. Earlier, I mean, still, I mean, there are some mixtures also. They mixing that gasoline. They mix gasoline and alcohol also. Now there are some engines, they completely run by alcohol, right? We take alcohol as a sustainable fuel, right? Sustainable fuel means, I mean, you know, we extract crude oil, we extract gasoline from crude oil. Crude oil is limited, but alcohol, is it limited? Alcohol, no, we can make alcohol as much as we can, right?
Yeah.
It's formed due to microbial activity, not bacteria. It's formed due to microbial activity, so we can make it as much as we can, right? Nothing wrong with that, right? Alcohol. But gasoline, we can't make gasoline. Gasoline comes from crude oil, right? So people develop some vehicle engines. Some ones run with the mixture of alcohol and gasoline, and some vehicles they can run completely under alcohol, right? They use different type of alcohol. So most of the organic compounds we can burn, and they are flammable, right? You know, acetone, that's also flammable, right? Acetone, almost all the things that we know, I mean, if it's organic compound, it's flammable, right? We can't imagine something doesn't flammable, right? Whatever you think, it's flammable. Alcohol flammable. Alchemy, these hydrocarbons flammable, right? Some hydrocarbons doesn't looks like flammable, but they aren't flammable because they aren't reach enough condition to burn, right? Otherwise they will also burn. I mean, like, you know, grease. Do you know grease? Grease we apply for vehicles, and yeah, right? So grease doesn't burn easily, right? But it will burn under heat, high temperature. It will burn. It will start to burn, right?
Yeah.
Okay, that's it. So write down burning hydrocarbon fuels. First point, burning hydrocarbon fuels in excess oxygen.
Yeah.
Burning hydrocarbon fuels in excess oxygen. Oxygen results in complete combustion. Result in complete combustion. Right. Complete combustion. It produce
Yeah.
it produce carbon dioxide and water vapor. It's produced carbon dioxide and water vapor. It's produced carbon dioxide and water vapor. Write this equation. This
Okay.
when they say complete combustion, you have to write this one. Huh? When they basically
Okay.
combustion means we use complete combustion. Especially we call complete combustion. If they ask, if they say incomplete combustion, you can't write this one. Huh? There's no
Mm.
exact one for incomplete one because it releases carbon. It's depend on the amount, right? If you have a very low amount of oxygen, it releases more carbon and carbon monoxide, right? That's the theory. Here you don't need to learn about incomplete combustion. But the theory, when the oxygen amount getting lower and lower, it produces more and more carbon and carbon monoxide. If it
Mm-hmm.
has higher oxygen concentration, but I mean not enough. I mean, if you have a, I mean, little bit lower than max enough required level, then it's produce more carbon dioxide and H2 and small amount of carbon and carbon monoxide. Okay. Then
Yeah.
the next one, right for octane. Octane means gasoline, right?
Mm-hmm.
C8 H18. So try to write the balance equation for combustion of this one, octane.
Carbon and water, right?
Yeah.
Carbon dioxide and water. Yeah.
Balance it. Huh?
Okay.
You have to balance some reactions, I guess, in the paper.
Okay.
Finish.
Yeah.
Okay. C8 ne? C8 means first 8 CO2. This is not the final one, just balancing, right? And then 18 is 9 H2O. Then
Yeah, it's gonna
how many?
be
Yeah, we had multiplied. Here is 9. 9 plus 8, 16, 25, 25. This one get 25, then with this one 2, this one 16 and 18. Yeah. This is complete combustion of octane.
yeah.
Then write down next subtopic, no, next reaction. Substitution reactions of alkanes. Substitution reactions of alkane. From here, the important reactions will start. Substitution reactions of alkane. Substitution reaction.
Yeah.
Right? First, we should understand what is called substitution. Right? Substitution means it's a replacing, right? Keep it in your mind when you saw the word called substitution, that mention something replaced, right?
Yeah.
This reaction, when this reaction happen, one part of the compound or the carbon chain molecule, one part of the molecule will change, replace, right? Replacing, right? Then there's another type called addition, right? Addition means combining, right? I will explain when it comes that part, right? Substitution means replacing. So here, these hydrocarbons, right? Hydrocarbons, alkanes doesn't show any reactions actually, right? It's a very stable one. It doesn't have any unsaturations, right?
Yeah.
Therefore, it shows very few reactions. Very few means even that reactions happen under special conditions, right? The
Yeah.
burning is the most common one, right? That can do burning. That's it, right? Only burning. And there's another one, the very common one we talk about, even that's happened under special condition. Substitution one. Alcohols on remember sorry, alkanes. Remember, alkanes only shows this substitution reaction type. Okay,
Yeah.
alkane. It's only shows it's common reaction type is substitution reactions, right? Because it can't do other reactions, right?
Yeah.
It's just a carbon and hydrogen. We can't break carbon, right? We can't break carbon easily, right? Even if we break that, we will get another hydrocarbon, right?
Yeah.
Breaking hydrogen here, the one is breaking hydrogen, right? Here, what happened? Substitution reaction, which is we gonna make. It shows a reaction with halogens, especially Cl2, right? Cl2, halogen, right? Halogen. Halogen. This is the only reaction you're gonna learn about alkane, right? So even university level, that's it, right? These hydrogen will replace by chlorine, right? These hydrogen atoms will replace by chlorine. That's why I call it substitution, right? You can say hydrogen substitute by chlorine, right? This
Yeah.
hydrogen atom substitute by chlorine, and the specialty of this one, this to happen, this thing you need UV light, right? This thing happen under UV light. This is the final complete. This is complete one. I'll get CCl4, CCl4 plus HCl. Right? I did Cl. This is the basic reaction, but it doesn't happen in this way, right? Directly. So, have you heard about something called chain reactions?
Yeah.
Chain reactions.
Mm-hmm.
Huh? Have you heard chain reactions?
Yeah.
Chain reaction means it's like a domino effect. You know, domino effect. Every step. One, then next one, right?
Yeah.
Each steps are related to each other, right? If previous one doesn't happen, then next one doesn't happen, right? Likewise,
Yeah.
chain reaction, right? Orderly happened, right? So this is a chain reaction, right? Not all the hydrogen replaced at same time, right?
Yeah.
So it's happened step by step, right? So under UV light, this CH4 and Cl molecule form for your goodness. You don't have to. In a chain reaction, there are several types of reactions: chain continuing reactions, chain uh, initiating reactions. There are several types, but here you don't need to learn those steps, right? This basic reaction is enough, right? I just explain a little bit about those things. Chain reaction, it has several. Under chain reaction, a lot of reactions happen, right?
Yeah.
So there are some several types, right?
Mm-hmm.
Chain initiating, that means there is a one reaction, this whole process starts, right? Actually it start by Cl, right? It starts by Cl actually, right? It's converting to this Cl molecule break with UV and form 2Cl, right? This is, what is this? Have you heard about something called radicals?
Yeah.
Okay. It's form radicals, right? These radicals are continue the reaction. If these radicals doesn't form, this reaction doesn't continue, right? It doesn't
Yeah.
start even, right? So you don't need that in your level, right? Because it doesn't in the book. But just learn there are some things, right? This is the way it start, right? It's form Cl radicals. These Cl radicals then continue the reaction, right? Right?
Mm-hmm.
Because they ask the basic one, right? Then you don't need to learn the bigger one. Right? Then its form. Initially, only one hydrogen is removed, right? One hydrogen is removed, and it's replaced by Cl. I will show the bigger one, right? The exact chain reaction.
Mm-hmm.
You don't need that, but I'll show it. Then it's form HCl, right? This is the basic reaction, right? Then
Yeah.
this one, this molecule goes to next step, right? Very easy for you. Then same thing happen. Another Cl2 react, remove this H and replace Cl.
Yeah.
Right? This one. Right? Then C. Then you substitute 2Cl, 2Cl, and then HCl. Then this one goes to next step. Step by step you replace every hydrogen around the carbon, right? Then HCl. Right, then the next one. This one goes to the next level. HCl. This is what happened, right?
Mhm.
But let me show the real, the bigger one. It does not in your syllabus, but it's better to know there's a bigger one. Right? Can you see this is the first one, right? chain
Mhm.
initiating, chain initiating step, right? Then then see, this is how it's happened, right?
Yeah.
Cl radical take hydrogen and it's formed CH3 radical, right? Then that CH3 radical combine it, break the Cl and then goes to next level. Right, likewise.
Mhm.
This is chain, right? Then here are the chain terminating steps, right? These steps stop the reaction,
Yeah.
right? These radicals stop, right? You don't, luckily you don't need that, right? I thought I thought you have that level. No, so it's
Mhm.
easy, right? So we wrote the topic, ne, right?
Yeah.
Then write down the definition of substitution reaction first. Write down a substitution reaction occur. A substitution reaction occurs. A substitution reaction occurs.
Yeah.
A substitution reaction occurs
Mhm.
when an atom or functional group. When an atom or functional group. When an atom or functional group. Atom
Yeah.
or functional group in a molecule. In a molecule is replaced or is replaced or
Yeah.
substituted by substituted by substituted by another atom substituted by another atom or
Mhm.
group, another atom or group,
Yeah.
right? Write the next point. Alkanes undergo substitution reactions. Alkanes undergo
Mhm.
substitution reactions with
Yeah.
halogens with halogens
Mhm.
with halogens with halogens, full stop.
Yeah.
At room temperature,
Mhm.
at room temperature and in the dark, in the dark, in the dark,
Yeah.
in the dark, methane and chlorine gas will not react. Methane and chlorine gas will not react. In the dark, methane and chlorine gas will not react.
Yeah.
Next, next, to occur the reaction,
Mhm.
to occur the reaction, it's need UV light. To occur the reaction, it's need UV light. To occur the reaction, it's need UV light.
Mhm.
Right. Then In the next rule, write mention this is a chain reaction. This is a chain reaction. This is a chain reaction. This is a
Yeah.
chain reaction. Right. Okay. Then write this. Write these 4 steps. This may ask in the exam. This thing.
Okay.
This are. These 4. 1, 2, 3, 4. You have to remember that. No need to remember. You should understand. Then you can write it by yourself. Right.
Yeah.
Each step, Cl is replacing, hydrogen is replacing it. Right, you can easily write it. In our one is hard.
Wait, so you want me to copy this?
Yeah.
Okay.
These 4. 1, 2, 3, 4. 4 reactions.
Okay. Okay.
Right. Then write down addition reactions of alkenes. Addition reactions of alkene. Addition reactions of alkene.
Yeah.
Right. As I said, alkenes are reactive than alkanes, right? Because it has unsaturation. Unsaturation means CC double bond, right? It has CC double bond. This bond, right? So due to this bond, it shows addition reactions. Addition means this bond is open and addition happen. Different things, it can add different things, right? Maybe another hydrogen, maybe another Br, right? Whatever, right? Addition reactions happen, right? Addition means not replacing, not substituting, right? Addition to happen, addition reactions, it's required double bond, right? Not only CC double bond, it may be CO double bond, right? So addition means basically it goes to here. I mean, actually it's replaced double bond, right? Not any other elements, other atoms in the molecule, right? It's open the double bond and then binding, right? Making bonds. Addition. So that's the common type. That's the common reaction type shown by alkanes and alkenes. Alkenes also, alkynes, alkenes and alkynes. Alkynes also unsaturated, right?
Yeah.
So here we talk about that kind of reactions, right? And also alkenes also can burn. Alkenes also burn, and we can burn it also, right? Yeah. So write down. So we wrote the topic addition reactions of alkenes, right? We wrote the topic addition reactions of alkene.
Yeah.
Right. So due to the unsaturation, due to the unsaturation, due to the unsaturation, due to the
Yeah.
unsaturation, alkenes are reactive than reactive or active, whatever. Alkenes are reactive than alkenes are
Alkanes.
reactive than alkanes. Yeah, alkanes. Alkanes. Next point, the common reaction type of alkenes, the common reaction type of alkenes are addition reactions. The common reaction type of alkenes are addition reactions. Addition reactions. Continue. In this type, in this type, small molecule or small molecule or atom, small molecule or atom added to the double bond of alkene, added to the double bond of alkene, added to the double bond of alkene. Right. Then let's go to example. Right. With the HBr, its form, right? So this double bond open, and then these bonds also break, right? And they goes to that double bond, right? Replace the one bond of double bond, right?
Yeah.
So what happened? There are several things happened here, right? There are several things happened. One is this double bond become single bond, right? This double bond becomes single bond, then we just remove it, right? And you know the shape of the carbon, what happened to shape? What is the shape now? Here, shape around the carbon. What is the shape?
It's
Trigonal,
like
planar, right?
trigonal.
Trigonal planar, right? Trigonal planar. Then now each carbon has 4 bonds, right? Because the bonding, right? Then what 4 bonds means? Tetrahedral.
Hedral.
Yeah. This is the Br form. Br hydrogen form. This. Okay. I'll write it in red color. So shape is changed and bond become double, single bond, and that means it forms saturated compound, right? Unsaturated one become saturated one, right? Then Yeah, generally that's it. Okay.
Mm-hmm.
Give me a second. Right. Write down reaction with HBr. Reaction with HBr. Reaction with HBr.
HBR.
Yeah, HBr. Wait. Right. Write this one. Reaction of HBr and then show this equation.
Okay.
Then write with this star. During addition reactions, during addition reactions, during addition reactions,
Yeah.
addition reactions, CC double down by down during addition reactions, then down by down. Na?
Okay.
During addition reactions, then first point, CC double bond, right like this. CC double bond, this one becomes CC single bonds. This one becomes CC single bonds.
Mm-hmm.
Right. Next point. Next point. The shape of the carbon atom.
As the next point.
The initial shape of the carbon will change. Initial shape of the carbon will change. Initial shape of the carbon will change. If you like, mention it. Trigonal planar to tetrahedral. Right? If you like, mention it. Right. Next point.
Mm-hmm.
The atom of the small molecule. The atom of the small molecule. The atom of the small molecule adding to the alkene, adding to the alkene, adding to the alkene, adding to the alkene, adding to the
Yeah.
alkene are adding to the alkene are added across the double bond, added across the double bond, added across the double bond,
Mm-hmm.
added across the double bond. Right. Okay. Then, so this is example and this is the thing happened. This the theory, right? This theory common for every addition reaction of alkene, right? This theory is legit, right? Every addition. Then so write down, leave a rule and write down, leave a rule and write down. Alkanes can undergo 4 different type of addition reactions. alkanes can undergo 4 different type of addition reactions. Alkanes can undergo 4 different type of addition reactions, right? 4 different type of addition reactions, right? So the first type, reaction with hydrogen, right? First one, reaction with H2, right? We can replace that double bond using H2, right? It's addition. The second type, reaction with halogen. Reaction with halogen. And the third type, reaction with halo halogen. And the fourth type, reaction with acids, water. Right? These are the 4 types that you're gonna learn here, right? That's in your syllabus, I mean textbook, right? So write down these 4 types. Reaction with H2, reaction with halogen, reaction with halo halogen. Sorry, yeah. Reaction with halo halogen, and third type, reaction with hydrogen halides. Sorry, hydrogen halides. Hydrogen halides, right? Reaction with hydrogen halides. And next type, reaction with what? These are the 4 types that you're gonna talk about. Right. Then write down a subtopic, reaction of alkenes with hydrogen. Reactions 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 with alkenes with hydrogen. Right here, we just talk about the example, right? So you should focus on the bond. That's it, right? I mean, whatever the carbon, I mean the carbon chain or the carbon structure, right, molecule, if it has a double bond, this reaction can be happen, right? Here we talk about the double bond, right? Whatever the molecule, if it has a double bond, this reaction will happen, okay? Not only for these reactions only doesn't only for the molecule that we talk about, right? Here we focus on the bond, I mean double bond, right? Whatever, if it has 10, 20 carbon, whatever, right? Whatever the other functional groups, right? It doesn't matter, right? This reaction happen if there is a unsaturation, right? Or the double bond. Clear? Right?
Yeah.
If there's a double bond, this thing happen. That's it. Okay, reaction with hydrogen. So here we can remove the double bond. We use this method to remove double bonds, right? Remove the double bond, and double bond means to remove the unsaturation. Remember, from the beginning, I explained to you about margarine. Margarine, you know margarine, right?
Yeah.
Yeah, Astra. I mean, I don't know. You have Astra, right? I mean, here we have Astra, right? So whatever, margarine, right? How do we make margarine? We make margarine.
Palm oil.
What are the materials we use? We used oil, right? Basically oil. What kind of oil?
Palm oil.
You know, I mean, yeah, palm oil, exactly. Palm oil, canola oil, and that kind of bullshit, right? So that oils are unsaturated, right? They are unsaturated bonds. They have unsaturated bonds. So what they do, they process that oils, right,
Mm-hmm.
They process that oil until they get single bond, right? So
Yeah.
that's what they do, right? This is what they do. They just remove the double bond using this reaction, right?
Mm-hmm.
What is this reaction? Which is called hydrogenation, right? We can
Yeah.
replace this double bond using this reaction, right? What are the things we need? We need hydrogen and we need catalyst, right? We need catalyst. So you have to remember that we use metal catalyst, right? Metal catalyst. Here we use nickel, right? There are few also, right? Not only nickel. And what we do, we just heat it, right? So that's why people said margarine is a highly processed food, right? Margarine is a highly processed food, right? If you look at the, I mean, when we learn this reaction, you might think, it's just one reaction and it's okay. No, it's not that much simple, right? You can't eat just after convert. There are some another process also, right? Right? You can
Mm-hmm.
make margarine, but just after this reaction, you can't eat it, right? Okay.
Yeah.
To make it edible, they have to purify it and then they have to do a lot of things, right? So that's
Mm-hmm.
why they said margarine is a highly processed one. And if you look at the ingredients, you can see hundreds of ingredients, right?
Mm-hmm.
You know, it came to replace butter, right? It came to replace butter, margarine. Margarine came to replace butter. What are the things contained in butter? Butter also saturated one, right? Butter contains saturated hydrocarbon. Butter contain only milk fat. Basically, milk fat butter contain. That's it. Nothing else. But this extra, right? It's contained hundreds of chemicals that we haven't heard about even, right? So this is the basic principle they use, right? This is the basic principle, the same exact one, right? So if they ask the users, not in your exam, but if somehow ask the users of this one, the use is margarine production, right? Making
Yeah.
margarine, okay? So then what happened? This one convert into alkane, right? We use this method as a making alkanes also, right? To forming alkanes. Right. Simple, just and may there's a temperature also. They haven't mentioned it. Just keep it in your mind. We have to heat that. Huh? I'll
Mm-hmm.
the mark heat. Otherwise, it doesn't happen. Um, do you have an idea how these catalysts work? That is in the syllabus. But
It speeds
yes.
up the reaction
Yeah, it's speed up the reaction.
by providing an alternate chemical pathway.
Yeah, altering the chemical pathway. Yeah. Um, haven't you learned how it's happening? I mean, molecular level, how it's altering the pathway? It's
No.
like, mm, I'll give example, right? It's like the thing it's do basically. It isn't in the syllabus, but I'll explain. Let's say there is a boy and there is a girl, right? So the probability of matching them very low, let's say very low, right? Then there's another person, another boy, right? What he do? He just make a match, right? And then he just combine them and he just leaving, right? Now we have a couple, right? that kind of things do, right? So actually that kind of thing, right? There are different mechanisms, right? There are different mechanisms. It's, I mean, for work of catalyst, right? Here, what is, haven't you learned work of enzymes? How enzymes work? No, no,
Oh,
any
in
mechanism, right?
biology, yeah, yeah,
Yeah, biology. Yeah, yeah, I'm asking biology, right?
yeah,
It's similar. What it's doing, that proteins, enzymes, it just took two molecules and let them combine. Ne? It
yeah,
has a specific surfaces, right? It's similar to here. It has surfaces, right? So they just take the two particles into the into
oh,
that structure.
substrate. That's the
Substrate, we call
substrate.
substrate.
Yeah,
Ah, right. So then they can make a bond similar, right? Just took
yeah.
them, contacting them, and make a relation, and then they just leave, right? The enzyme stay alone, right? Right. So that kind of reaction happened here, right? This nickel make a surface, right? Substrate, right?
Yeah,
This nickel make a substrate for the hydrogen and this double bond, right?
yeah.
Just attract the hydrogen and then break that bond and then make a bond with them, right?
Mm-hmm.
It's kind of similar, right? That's the way metals act as a substrate, right? Act as
Yeah.
a catalyst. Most of the time they just make a substrate, then they let the reaction happen, right?
Mm-hmm.
That's why we use different metals for different reactions, right? Those substrates are differ, differ from each other, right? Substrate
Yeah.
are differ from each other, right? So let's write down a little bit. Mm. Alkanes react with H2 and alkane reacts with H2. Alkanes react with H2 with the presence of, write down, alkanes react with H2 with the presence of metal catalyst, with the presence of metal catalyst, with the presence of metal catalyst, like nickel, like nickel, like nickel, and then form al alkanes, then form alkanes. Then write the equation. This one. I'll come.
Oh, I can't hear you.
All right. Um, then you haven't heard the topic. Write the topic. Reaction of alkenes. Reaction of alkenes with halogens. Reaction of alkenes with halogen.
Okay.
Right. So halogen means things like Br2, Cl2, right? Okay. Br2. So what happened? As here, it's place the double bond and combine with carbon. Right. So here it doesn't require any catalyst or something. When you mix them, it's automatically happen, right? So write down. The halogen adds, first point, after the topic, the halogen adds across the double bond, double bond of molecule, double bond of molecule, double bond of molecule, then it's form a product, with one bromine atom attached to each carbon atom. One bromine atom attached to each carbon atom. Next point. This reaction doesn't need catalyst. This reaction doesn't need catalyst. And happens at room temperature. Right. We then write this equation.
Okay.
Finish. Drew it.
Yeah.
Oh. Right. Then another one. We use this test, right? We use this reaction as a test for alkene, right? Alkene, because it shows a color change, right? It's decolorized the bromine, right? It's decolorized the bromine. You can see that diagram also. Right. Turn page number 314. So look at the diagram, right? They shows a color change, right? When you add bromine into the test tube, bromine and alkane into the test tube, it shows two layers, and then after that, the color of the bromine become colorless, right?
Yeah.
The solution become colorless, right? It's happened due to the bromine react with alkene and goes through the double bond.
Yep.
And break the double bond and form Br, right? So we use it as a identification test, right? Test. So remember that. Write down bromine used to identify CC double bond. 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 The orange color of the bromine, the orange color, write down the orange color of the bromine, the orange color of the bromine,
Yeah.
the orange color of the bromine quickly disappear, the orange color of the bromine quickly disappear when mixing with alkene, when mixing with alkene, when mixing with alkene, right? Just put the star, right? Star එකක් දාන්න, right? Put the star, right? Clear?
Yeah.
Right? Sometimes they may ask identification test also, right? How to identify. It's better to know.
Yeah.
Then, so what happened if you had alkane and Br2?
The
Alkane.
alkene and Br it
No.
decolorizes.
Yeah, okay. Alkane. What happened with alkane? Alkane and Br.
It will become orange.
Yeah, I mean nothing happened. What should
Oh,
happen?
nothing
Right?
happens. Okay.
Nothing happened,
Yeah.
right?
Oh, okay.
Nothing happened. No way to react, right? Okay.
Oh.
No any changes. Write down next type, reaction of alkenes with hydrogen halides. Reaction
Okay.
of alkenes with hydrogen halides.
Mm-hmm.
Reaction of alkenes with hydrogen halides. Right. Here it's similar to the initial one we drew. Next. Here both carbon are similar, right? The number of hydrogen bonded to the carbon is similar, 1 1, right? So therefore this product doesn't change, right? I mean it's doesn't change means there's a important thing here, right? So you can draw as you wish, it doesn't matter, right? But when it comes to compound like this, this one H, this one H, this one CH3, and this one H. Here something changed, right? You can't draw the structure freely, right? So the compound formed in this case, the Cl, this Cl exactly goes to this carbon, right? Cl,
Mm-hmm.
you can see these two carbons are different now. This one has
Yeah.
more hydrogen, right? This one has 2 hydrogen, and this one has only 1 hydrogen.
Yeah.
So Cl, or I mean halogen, this is valid for Br, whatever, right? This halogen exactly goes for the carbon with lower hydrogen, right?
Mm-hmm.
You have to draw that structure. Otherwise, if you put the chlorine into here, it's wrong. It's wrong, huh?
Yeah.
There is a rule also. There is a reasons for that. There is a reason for that, but you don't need to learn that here. They don't ask you to learn it, right? right? So right, you the reality is, right, during this reaction other product also formed, right, other product also formed, but it's formed very small amount. Okay,
Mm-hmm.
that's the real thing. Generally we don't draw this structure, right, but it's form very small amount, this one. You can see first, can you understand these two are two different compounds,
Mm-hmm.
right? This one, if you name it, you will get 2 chloro something, right? This one 1, right, 1 chloro something, right? So this product, if you get a percentage, you will get 1%, 2%, right? But this one 98, 98%, 99%. This is the main product, right?
Mm-hmm.
So generally we draw this product when they asked the product, right? If they ask
Yeah.
possible products, you have
Then
write
the other one, both
both,
of them.
right?
Yeah.
Yeah, you have write both of them. That's the theory, right? These two are possible, right? But mainly produce this one. Clear?
Yeah.
That's the important part. Okay.
Okay.
This is valid for HBr, HI, whatever common among the halogens, right?
Yeah.
Write down hydrogen halides are hydrogen halides are compound that contain hydrogen halides are compound that contain one hydrogen atom and one hydrogen atom and one hydrogen atom and one hydrogen atom and one halogen atom, one hydrogen atom and one halogen atom.
Mm-hmm.
First point. Okay, then next point, next point, next point. In this reaction, in this reaction, in this reaction,
Yeah.
a hydrogen atom is added to a hydrogen atom is added to one carbon. A hydrogen atom is added to one carbon. Hydrogen atom is added to one carbon, and halogen atom added to one carbon atom, one carbon atom in the double bonded carbon, right? The double bonded atom by replacing double bond, by replacing double bond, by replacing double bond, right? Then write the first equation, only the first one, only the first one. Finish, do this one.
Yeah.
Right. Okay, then write leave a rule and write down addition of addition of addition of addition of but 1 in addition of but 1 in addition of but 1 in Addition of but1ene with HCl, 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 HCl. Two isomers are possible. Two isomers are possible. Two isomers are possible. Then draw this diagram, equation. Draw this equation. Here it's not plus, it's O. This one or this one. Mention it as a dominant product, a main product, main product. No? Main product.
Okay.
Right. Then, right. You mentioned which one is main, which one is this one is main, right? Then write to this star. In this case, in this case, halogen atom bonded to carbon with lower hydrogen. Halogen atom bonded to carbon with lower hydrogen. And hydrogen atom bonded to the carbon. With higher number of hydrogen. That's how you identify it. Huh? In the exam, if they ask the product, main product, you have to identify which one goes to which carbon. Right? But check the number of hydrogen, right? You have to check it. Understand, find it using the number of carbon, hydrogen. Right. Right. Okay, then write down reaction of alkenes with water. Reaction of alkene with water. Right. May another thing. In your paper, you don't get, several organic questions, right? Not that much, ne? You have how many questions in your paper?
There's 4 modules, so the paper has like a quarter of organic.
Right.
Because there's 4 modules, so the paper has to be evenly split into 4. So half of 1/4 organic, 1/4 acids and bases, 1/4 equilibrium.
Yeah. You had to study other parts also well, right? Not only this part is enough, right? Yeah. When I look at the paper, I found several organic compound questions. That's why. Now you can do few questions, but need more. Okay. Right. Here. What happened? Reacting with water means we just break the water and then we add into the double bond, right? See what happened. This is a catalyst, right? And then 300 Celsius. Right. So what happened? Actually, there are some mechanisms, right? There are some mechanisms, right? But it's not in your course, right? It's not in your syllabus, right? So it's easy thing you have to remember, right? This thing, when you add this thing, you will get something, right? Whatever, right? You
What
have to
does the
remember.
stuff near the arrow say?
Huh?
What does the stuff near the arrow say? I can't read that.
Ah, wait. H3PO4, and this is catalyst.
Oh, okay.
And then we'll get hydrogen. H and OH. Right? So nothing to explain. Just break the water molecule into H and OH and then add into the double bond, right? There's another part here. Let's write down and then I'll explain that part.
Mhm.
Then, because this concept, this one again happened when you add water. Okay, write down. So remember this reaction. Remember this reaction as a reaction that produces ethanol, right? Reaction with water, it's okay, but remember it's as a method of producing ethanol. It's enough.
Okay.
Right. Write down alkanes. Alkanes react with water. Alkanes react with water under specific conditions. Specific conditions. Conditions to make alcohols. To make alcohols. To make alcohols. Right. So we can do the same thing using sulfuric acid also, right? I'll write it later. So for now, just write this one.
Okay.
H3PO4 as a catalyst and then 300 Celsius. Wrote
Okay.
it?
Yeah.
Wrote the equation? Ah, you already wrote it?
Yeah.
Ah, I thought. Just wait. Just wait when until I ask.
No, it's like produces alcohol. I wrote produces alcohol.
Producing alcohols.
Yeah.
Yeah, that's it.
And
That's it. Yeah, that's it.
okay.
Then this reaction again said hydrogenation also, huh? Because we had water molecule hydrogenation.
Oh.
Right. So here, see what happened. Huh? CCH. right? Same theory apply here, this one, right? So it has two possible two possible products, right? It has two possible products,
Okay.
right? So this one hydrogen, this one OH, this one OH, this one H. So similarly, this is the main product, right? This is the main
Mm-hmm.
product, and this is the
Secondary
what you
product.
call it? Yeah, secondary. Yeah, secondary product, and it's produced very small amount. So write down just like the reaction with hydrogen halides, just like the reaction with hydrogen halides, just like the reaction with hydrogen halides, the reaction of asymmetric alkenes, 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 the reaction of asymmetric alkenes with water, with water produce two isomers, two isomers with uh, two isomers, two isomers. That's enough, right? Two isomers, right? Two isomers. Next point. Next point. Similarly, similarly, OH bonded with OH bonded with carbon, OH bonded with carbon that has lower hydrogen atoms bonded with carbon that has lower hydrogen atoms, and hydrogen bonded with carbon, hydrogen bonded with carbon that has higher hydrogen atoms, higher hydrogen atoms. Okay, mention the equation. Mention. Right, finish all the right. Then right, right. I missed this part. Now that may hydrogen is right. This reaction also called hydrogenation, right? No need to write that name. Remember that. Huh? If they use name hydrogenation, right?
Okay.
It's called hydrogenation reaction, right? This reaction
Mm-hmm.
happen with the steam. Huh? See, Celsius 300, right? So this
Yep.
reaction happen with the steam. What is steam? Huh?
Yeah.
So it's called hydrogenation,
Yeah.
right?
Yeah.
Um, so that part is over now.
Mm-hmm.
How just show me. I mean, what are the problems that you can't do in previous exercises? If you didn't do, it doesn't matter, right? If you try to do and if you can't, is there any questions that you can't do?
The stuff that I did do, I could do.
Okay.
but maybe
This
the
stuff I
end
didn't
line.
do. Yeah. Okay, okay. If you can, then it's okay, right? I mean, if you can't, then
Yeah.
it's a problem,
But
right?
maybe like
So,
towards the end, there's gonna be harder questions. So then maybe if it's hard, then I can ask you next week.
okay, okay, okay. Then, uh, what shall you do? Continue to next part? Board? Yeah. Okay, okay, and then stop.
Oh, okay.
What to do? I can say when I'm looking at you.
Oh,
Yeah, the next part is alcohols, and then let me check how much left. Alcohols. I have to it's there. After alcohols. You don't have any other, I mean, mainly alcohols. I mean, that Pearson book, is it contain all the syllabus? It's contain?
yeah,
Pearson book
yeah,
contain all syllabus, ne?
yeah.
Yeah.
But the chapter names are different. Like chapter seven is not like it's not chapter seven. The syllabus and
Ah,
the Pearson, yeah,
I mean, the content is similar,
the
right? I mean, the
content is
numbers may
yeah,
be changed, but the
yeah.
content
The
is similar,
content
ne?
is yeah.
Right. We can complete the alcohols next week easily,
Yeah.
right? Very small part, and then yeah, we can complete all. I mean, next week, or maybe next week, definitely after next week, we can complete
Okay.
the organic part. Yeah, I mean, then let's do some exercises. Yeah,
Yeah.
within 2 weeks we can. Within two,
Oh,
definitely we
okay.
can
Yeah.
easily.
Because the test
Um,
is on the 18th of June. So,
okay, then you asked to do another part also, ne? How about other lessons? The initial lessons?
oh, I think I got that because, yeah, I think I got that pretty okay. But there's just one
Right.
more module after organic, which is module 8, and that's
Okay.
like application stuff.
Application stuff. Ne?
It's
Yeah,
in
we
the
can
syllabus.
finish organic, I mean. It doesn't matter. Then we can do a lot of papers, ne? It's good, ne?
Okay.
We can do the papers, and when we do papers, I will remind the other parts. That's good, ne?
Okay.
I can remind
Okay.
other parts. I mean, what's in there? I mean, acid bases, and did you have
Okay.
equilibrium?
Yeah.
There. How about equilibrium? Is it easy?
Yeah, it's okay.
It's okay. Everything is okay.
Whoa.
Okay. It's okay. Ne? It's all right. Ne? Let me check what's in there. Mm. Equilibrium and acid reactions. Ne? Module 5. Acid base reactions. I mean, this test, I mean, your final test, so they, they just ask about may acid bases and then
Equilibrium
organic
and
and applying
application.
chemical ideas.
Yeah.
And what else? Yeah, ne, that's it. Ne?
Yeah.
Equilibrium and chemical acid reactions. Four
Yeah.
modules,
Just
right?
four. Yeah. Yeah.
Right. That means, then how about the previous parts? I mean, you wrote the exam for previous part.
Like year 11,
Year
grade one.
11 contain the initial part. I mean, one, 2, 3, 4,
Yeah. And then 5, 6, 7, 8 is year 12.
12. So much easy, ne?
But they're only examining 5, 6, 7, 8. But 1, 2, 3, 4 is like assume knowledge. So you build on 1, 2, 3, 4.
Right. They haven't asked to learn, but they will ask some questions
No,
from
like
that.
you need. you need 1, 2, 3, 4 to do 5, 6, 7, 8. But they're not gonna
Ah,
ask
right,
questions
right.
from 1, 2, 3, 4.
They don't ask questions from 1, 2, 3, 4. They only
No.
your questions mainly based on 4, 5, 6, 8. Ah,
Five,
right,
six,
right,
seven,
right.
eight.
Five, yeah, 5, 6, 7. Yeah. Then you wrote the exam for 1, 2, 3, 4.
Yeah, but it's not like counting towards anything. It's like a term test.
Uh-huh. So
Last year
your final test is
is in
on
October.
October, October, ne?
October October 30th. But
Uh,
in August we have like a practice exam, like
uh,
with one two with
mock
five, six,
exam,
seven.
mock
Yeah,
exam,
mock exam. Yeah,
mock
in
exam.
August.
Right. Okay, yeah, now I have an idea, right? Because I mean, it's
Yeah.
totally different, right? I mean, in here we just learn 2 years, and then everything counts for the. You have write everything in the one exam, right? It's bad. I don't say it's good. I mean, U1 is better, right? You learn 4, 5, 6, 1, 2, 3 first lesson, and then roll the exam. Then they don't ask anything, and then write the answers for learning. Then easily, right?
Yeah.
Learning several lessons, and then face the exam. Easy. It's easy. Um, right then. So I'll stop here. So it's easy. It's easy. We can do papers after that.
Okay.
Yeah. Okay.
Okay,
Let's
thank
stop for
you.
today. Okay.
Okay, thank you. Bye
Okay.
bye.
Bye.